My name is Twan Altena and I am an application engineer at De Hoek van Kerosi. The flow rate and pressure of the electrolyte, which flows between the electrode and the workpiece, are really important parameters for the process. The electrolyte is responsible for conducting the electricity and transporting the sludge away from the process. Both have a direct influence on the final surface quality of the product. Due to the oscillating movement, the electrode will disperse the electrolyte and constantly changing the flow in the working gap between the electrode and the workpiece. Because of the high pressure and velocity at which the electrolyte is flowing, it is possible that flow lines may be visible on the final product because of erosion. These are especially visible on products with a high gloss finish. As mentioned, the flow of the electrolyte is changing constantly during the process in the oscillation. This is shown in the following schematic pictures. In this case, the flow is from the left side to the right side of the electrode. When the electrode is at its highest position, T0, the electrolyte will flow laminarly in between the working gap, flushing away sludge and providing new electrolyte. When the electrode starts to move down at point T1, it will pressurize the electrolyte and it will start to disperse outward under the electrode, limiting the incoming flow of fresh electrolyte. Once the electrode reaches its lowest point at T2, the electrolyte is fully dispersed in the working gap, almost stopping the flow of new electrolyte. At this point, the current is applied and dissolvement of the material takes place. After this, the electrode will move up again to point T1, reducing the pressure in the gap, allowing electrolyte to flow again. After this, it will move further up again back to point T0, flushing away all the sludge and providing new electrolyte. I would like to thank you for your attention and interest in the PECM technique. I will hope to see you later at De Hoek. Goodbye.